Hi, I'm Joel. I founded a company called Bigleaf Networks, but today I'm going to talk about low Earth orbit satellite like Starlink and how you can use that for business connectivity needs. Specifically, I want to answer a few questions like, can I use Starlink to address key applications like voice over IP or video conferencing or business apps like ERP, CRM, other line of business apps? Also, do I need SD-WAN to get the most out of Starlink, or can it work well standalone? And how does it compare with other circuit types, fiber or DSL, or even geosynchronous satellite or fixed wireless? Also, can you get a public static IPv4 address block over Starlink, which is commonly needed for a lot of business use cases? I have a unique setup to test any sort of connectivity, and I'm here at my home office, and notably I don't have any landline connectivity. I have three kinds of wireless connectivity: a fixed wireless circuit from a local regional wireless ISP or WISP, a cellular option, LTE connection that I make use of, as well as a geosynchronous satellite option. And so we'll add to those a LeoSat through Starlink and take a look at what it does. Satellite is commonly considered a less desirable connectivity option as compared to landline circuits like fiber or cable or DSL. And I think that the low Earth orbit satellite option, LEO, changes that story a bit. So we'll explore that. Notably, I'm going to be talking about Starlink today because that is the commercially available LEO satellite option in North America. And I just received my treat in the mail from SpaceX. My Starlink box. We'll unbox that and get it installed and connect it up into SD-WAN and take a look at how that works together. All right, let's open this box up. So we have the temporary mount. I have a permanent mount coming, but that was a little delayed in the Starlink order. We have the rectangular form of the dish, or dishy as it's affectionately called. This is their newer model compared to the circular one. Some nice pretty instructions. The indoor Wi-Fi router. Notably, it does not have an Ethernet port, so we're going to have a little adventure with that. I've ordered the Ethernet adapter, but it's not here yet. I think I have a workaround we're going to try to put in place. And then the Ethernet cable between the two. And the ever important regulatory notices. So we'll get this installed and get going. Starlink needs a clear view of the sky above to be able to connect from the dish to the satellites as they fly overhead. I found this temporary spot in my yard that I'll set the dish for now that has a pretty clear view, and later on I'll mount it up on the roof. We'll use the Starlink app to check how good of a spot that is. It uses some technology to scan the sky to see if there are obstructions that need to be avoided or if that spot will work well. I'm not sure if that technology is based on the LiDAR in the iPhone or if it's just optical, but it's pretty neat how they can do that. The result shows that this location is pretty good. There's some obstructions, but it should work well, especially for this initial testing. Here I've got the dish set on some rocks temporarily. It'll work okay unless it gets windy. And it's now plugged in, run the cable inside, and we'll get using it. Once I had the Starlink dish connected to their router, I went into their app and got the Wi-Fi set up and my phone connected to it. In the app, you can view stats like uptime and a log of outages, and also see some latency and throughput usage data. You can also run speed tests, which I'll show you here. Notably, they break the speed test up into 3 separate tests. This is between the phone and the internet, so running through the whole path of the Wi-Fi and the Starlink path. And then the separate tests after that will test from the Starlink router through the Starlink service to the internet, and then separately from my phone to the router. We can see in these tests the performance is quite variable, and I've seen that pretty consistently over time, that throughput, both download and upload, vary significantly over time, and that's reflected in these graphs as well as other testing that I've performed. Welcome to my networking rack here in the house. In here I've got a switch and my Bigleaf router, my SD-WAN router, and there's 3 WAN circuits connected. We're going to hook up the 4th today, although we'll have to get a little creative on that without the Ethernet adapter. What I'll do to connect the Starlink router into WAN 4 on my Bigleaf SD-WAN router will be to set up a VLAN in my switch and then connect that into the WAN 4 port. So here's my current home network diagram. I've got the switch, and that connects to a router, and I use a MikroTik router that runs on a form of Linux. And what I want to do is set up a connection to Starlink. We have the Starlink Wi-Fi AP, and that has an IP address 192.168.1.1 on it. I connected my MikroTik router as a client to it, and I set up some rules in that router to NAT traffic from my Bigleaf router through Starlink. So I assigned this private 192.168.6/24 subnet between the Bigleaf router and my MikroTik home router, and then the home router's NATing traffic out through Starlink. So there's at least 2 sets of NAT going on here, one in the MikroTik router, another in the Starlink router. But all in all, it gets a Bigleaf tunnel, a couple of them, established out through that path and off over Starlink. We can see here I'm logged into the Bigleaf web dashboard. I pulled up my house, and on the overview page I can see I have 3 WAN circuits configured so far. My fixed wireless, my LTE, and my ViaSat geosynchronous satellite connection. What I'll do is I'll go into our configuration tab here, go into edit mode, and I'll add a new WAN circuit. So this will be Starlink. And through the speed testing that I ran in their little iOS app, it was looking around 60 meg down and 15 to 20 up. Seemed fairly consistent. In the Bigleaf system, you want to set kind of a rough, reliable number here. Maybe I should make this one like 18 to make sure it'll be hit most of the time. The Bigleaf patented technology will actually adjust dynamically as these speeds change, so that's fine if they're not quite accurate, but giving it the AI a good baseline to start with is helpful. For type, we don't yet have low Earth orbit satellite as an option here. And so what I'm going to do is I'm going to pick enterprise fixed wireless. That's the most analogous to the performance of the LeoSat. So breaking news, we now do have low Earth orbit satellite as a specific circuit setting in the Bigleaf web dashboard. We added that between the time I recorded that original video and when I'm editing this now. So you can see, you can specify geostationary or low Earth orbit for your satellite type, and the platform will adapt accordingly. So I hope that's helpful. And protocol, I did set a static IP in my router, so I'll enter that here. And if I click Show Advanced Options, I could see these different options I have for how to use the circuit. You can see with the LTE circuit, my WAN 2, I am using custom. So for VoIP, for example, I'm load balancing traffic. For interactive like web browsing, it's backup only mode. And then for bulk data, block. So that way when my family's watching streaming video, they're not using up the bandwidth capacity we've got on that link, the monthly bandwidth available. My ViaSat here, I do have in backup only mode. Again, sometimes I'll use that. I'll typically use it actually in avoid mode. I've just been running that this way for a little while. So now that we've got the Starlink information set, we can go ahead and save, and that circuit will become activated. And just a moment ago, the tunnels came up. We now have some graph data. So we'll let this build up for a little bit. We can see the circuit's already been in use a little bit. Do see some alarms. Now we don't know if those are from the funky Wi-Fi connection between my MikroTik router and the Starlink, or if they're from Starlink. I'll have to do some digging on that. So I've been troubleshooting why the Starlink connection's been having really bad download packet loss. We could see that the loss is level 5 to 4 at times. But upload's been fairly healthy. And this is the Starlink circuit. We can see here the SD-WAN hasn't really been using it for download because it's been too unhealthy. I captured MTR data from our router to the core of the internet where the tunnel terminates in a Bigleaf POP, and see there's pretty heavy packet loss kind of midway along the link. This is an upload indication, but it's a round trip test because the IP from Starlink is not a static IP or publicly reachable. Download testing outside of a tunnel is pretty hard to do. But this tells us there's somewhere along this path that some notable packet loss is getting injected, about 4.5% end to end. So that 4.5% equates to this level 5 alarm in the Bigleaf platform. Now, in looking at the Starlink app on my phone, it was kind of unresponsive and acting weird. So I went out and rebooted the Starlink modem at this time period, and we can see the downlink loss has basically gone away. And now there's uplink loss, although that's reduced a little bit. So very odd behavior. Just we'll have to see how that plays out. Maybe I got to reboot it a third time and they'll both go away. But I'll take a look and see what we can do to get this clean and happy. Okay, so I discovered an issue with the funky wireless bridge setup I had going on. I resolved that here and rebooted things into what I think is stable actual Starlink performance. We need to make sure it's not any of the Wi-Fi that's causing this upload packet loss. So to do that, we'll go run a MTR from the Bigleaf router through the Starlink circuit. Here are the MTR results. We can see that there's loss on the second hop. The first hop is my MikroTik router, and that has the wireless connection to the Starlink router, the 192.168.1.1 hop. Since the loss appears at the Starlink hop, we know that the loss is happening on that Wi-Fi path. So I really need to get that Wi-Fi connection addressed, or rather removed, so I can then effectively test. All right, I'm back. So a lot's happened since I was last recording. It's been about a month and a half, and some things have changed. Firstly, in looking at some of the data I was seeing, I wanted to really make sure that I was isolating what's the Starlink performance versus what are other variables. So I got finally delivered the Starlink Ethernet adapter. It gives me a Cat5 based Ethernet connection into the system rather than having to use some kludgy wireless setup. So got that set up. The results from that indicate that performance improved, but not entirely so. It was around April 10th that I changed over to using that Ethernet adapter. So we can see, we'll just take a look at what this is the Starlink circuit, the Bigleaf health alarms, what the graph looks like before and after that point. So we can go back to this April 10th timing in the evening. So we can see kind of before that, there was a substantial amount of download packet loss and upload too, but we can see after this April 10th timing, right around here, the trend is downward in packet loss. The orange and the red is definitely less severe than it was before. So we know that going from wireless to a hardwired Cat5 Ethernet connection into the Starlink system did help. However, this is still pretty rough performance here. This is usable for plenty of use cases, but not where you want to be for if your business is going to be entirely dependent on that circuit. So what just happened last night, I finally was able to move the dish. I moved it from sort of a temporary install location where there was potentially some obstructions. I moved it up onto my roof where there's the best possible view of the sky, very little, if any, obstructions. So what we can see if we look at some of the recent time is, so last night around 8 or so, got that moved over. That was right about this time frame. And it's not been a dramatic change. Looks like they had an outage early morning this morning. But other than that, I mean, you can see that there were some days where it looked fairly decent. Today is similar to those. So it doesn't seem as though the location of the dish made a big difference. We'll see if that continues to be the case, but so far that's what the indication is. I want to address a few questions I think might be running through folks' minds. First, how do I think about Starlink versus most landline type circuits, fiber, cable, DSL, that kind of thing? And I think the health alarm data we can see is really useful to know how these comparisons sit. If I was to go pull up another customer site, which I'll do here. So here we have New Seasons Market. They're one of our customers. They've graciously offered to let us use their sites as demonstration sites, but I'll pull up a couple of their locations and let's see what they look like. So this location, we have some Comcast fiber. This is in Oregon. This is a typical fiber health graph. Literally nothing. This is in a nice, built up city area, so pretty healthy fiber path. And we can see it's entirely clean, no health alarms at all. This circuit above here, this is a cable circuit. Looks pretty clean as well. I mean, this is, users are not going to notice too much of what's going on here. You've got a little bit of jitter, upload and download at times. I would say this is pretty squeaky clean for a cable circuit. You can see them totally clean sometimes, but this is a nice cable circuit. We see them with plenty of packet loss and other issues at times. We'll take a look at another location here. This top circuit here is, again, Comcast fiber. So we can see, looks pretty clean. There's a couple blips, so this one could be user impacting. This is middle of the day. You have basically a mini outage. But other than that, I mean, totally perfect. And then Frontier Fios, we'll take a look at that one. Again, looks pretty clean. A couple blips there. Not too big of a deal. And this is typical for a landline kind of circuit. So back to my house. If you compare those graphs against the Starlink graph for a same time period, I mean, it's got periods, middle of the night, where it looks pretty clean, but during the day, there's definitely a lot of variability. And that's what I would probably highlight. With most wireless type connections, they're going to be more variable than a landline circuit, yet they are also a great redundancy path, right? So if you have a backhoe come through your area where your building is, dig up some conduit, your landline is going to fail, and your wireless circuit's going to keep on working. Throughput-wise, that can vary as well. So, fiber is typically going to offer you more throughput than what we're seeing with Starlink, which is around somewhere between 60 and 120 meg down, and upload is very variable, up from 0 to 15 megabit up at my location here. I've set it in the Bigleaf platform to be at about 70 by 10, just to give the Bigleaf AI the right foundation to work with there for throughput. Now, what about Starlink versus other wireless circuits? Well, my home is the perfect test case for that because all of my circuits are wireless. So if I take a look at the health of the other paths, let's take a look at ViaSat. So ViaSat is a geosynchronous satellite, and we can see that quality-wise it's actually very good. Now, this graph doesn't reflect the absolute latency of the path to traverse to geosynchronous orbit and back. The latency that our platform measures is in the form of relative one-way latency. So our technology does some things to adapt for that, knowing that geosynchronous satellite does have that higher latency just kind of in the background. But very low jitter, very low packet loss, so impressive from Viasat there. You might wonder, well, what's the difference between geosynchronous satellite and low Earth orbit satellite? And I drew a cute little diagram here to show that. So if you've got my house, the red depicts essentially what is happening with the low Earth orbit, where there's a shorter path from my house to the satellite to the ground station, which then is connected via fiber to whatever data I'm reaching, some data center. Whereas the geosynchronous satellite is a much larger distance, and this is not to scale. The difference would be more significant than what you see here. But that's the idea. And this satellite sits in one spot in the sky, so it's a very consistent experience, whereas the low Earth orbit satellites are moving around all the time relative to my house, so the platform has to transfer between satellites over and over again constantly. So the reason the latency is much lower is because it's taking a much shorter path, just geographically. The time of flight of the RF signals is reduced. Now, if we compare against the LTE circuit I have, the LTE circuit is much more consistent in its behavior and much lower in packet loss, but the throughput's a lot less. And when I've tested here, I'm getting about 4 megs each way on that circuit max. So a much more constrained use case, and there's a bandwidth cap on it. And then lastly, the fixed wireless circuit I have from a local residential fixed wireless provider. We can see that during times of load, there is significant jitter and packet loss and some latency at various times. So this circuit is, I'd say it sits in between the LTE and the Starlink as far as variability. So all in all, each wireless circuit does have its pros and cons, and you need to look at what's available in your area and trade-offs of throughput and performance characteristics. Now, what about a static IP address? That's something that a lot of businesses need to be able to deploy with certain use cases, VPNs or hosting a server, that kind of thing. And none of the circuits that I have a standard static IP address. They're all using a DHCP provided NATed IP address. And the nice thing is with Bigleaf, I actually have a static IP block. Bigleaf creates a tunnel across each of these circuits and delivers a single public static IP address over them, just like you would get if you had BGP in a very carrier-grade enterprise environment. So that's really nice for users who need that static IP address while using alternative circuits like wireless. Lastly, do you need SD-WAN to make use of low Earth orbit like Starlink? Well, in looking at the health of the circuits at my home here, I would say yes. I mean, if I had just this one circuit, or even if I had multiple circuits with a less sophisticated load balancing QoS mechanism, I wouldn't be able to do things like voice calling or Zoom, those sorts of sensitive applications in a reliable manner. And we can see examples of that here. So I had some Zoom calls this morning. All this green, what's it saying, VoIP was the Zoom traffic. And we can see that the SD-WAN platform really had to adapt hard to make best use of that. So here's my LTE circuit. It used that for upload traffic. This was around what time? 10:30 to 10:50 a.m. And we could see that the alarms were fairly low at that time. Level 2 jitter was all that it was seeing. And the downlink went, looks like in part on the fixed wireless circuit in that, let's see, 10:40, 10:50 time frame. It's kind of jumpy because it was, I think, moving the traffic around, and it's likely because alarms varied. So there's some traffic that ended up on the fixed wireless, and then other traffic ended up here on the Starlink circuit at that time. So the platform was adapting to make sure that each packet was riding over the best possible circuit. So if I didn't have that in place, my Zoom quality would not have been as good. Now, would it have been unusable? In this case, no. I mean, the Starlink alarms aren't terrible at that time. I mean, if they were level 4 or 5, yeah, at that point, that's when people are unclicking their video, they're going to just audio or saying, hey, can I call you on the phone? It wasn't like that, but it definitely would have been some level of user impact. Another SD-WAN feature of note that Starlink really will need to be successful in the business environment is something that can provide QoS over very variable bandwidth circuits. We built the Bigleaf platform to be able to do that with some patented technology where we can provide QoS prioritization over circuits that vary in throughput a lot. It was designed with sort of the notion of cable and fixed wireless and those sorts of platforms that can become congested. And Starlink, we find, has a very variable bandwidth profile. Here's some iPerf testing through the platform. We can see this is download testing. I mean, this is just raw iPerf traffic varying between 50 megabits a second up to 100. And that's a pretty significant jump back and forth in throughput. In the upload direction, we see traffic varies even more considerably, 9 megs down to 1 meg. and at times it would rise up to 15 meg. So a lot of variance in throughput, which means that if you just have like a static QoS policy applied to the circuit, saying it's 10 megs or something, that QoS isn't going to work. The traffic's going to hit constrictions within the Starlink service, get buffered and either dropped or delayed. So you need a platform like Bigleaf that can detect that variability in bandwidth, adapt to that, and ensure QoS prioritization through that path even as conditions change. So in conclusion, I think Starlink and low Earth orbit are fantastic technologies. I'm really excited about what they bring to bear for folks in rural areas like me and businesses that can't get good landline connectivity or need a really solid redundant path that offers more throughput than LTE can in areas where some of the more sophisticated 5G elements aren't available. Starlink gets my thumbs up. I think I would combine it though with SD-WAN and another circuit if you have any business critical use cases, and we'd be happy to help you out with that at Bigleaf. But thank you for watching, and look forward to sharing more with you again.